Namo Namaha. Namaste Sarvebhya Namaste. Shubhodayam. Let us start our session with Vande Mataram from Shishi Babu Garu will sing and all of us stand up and also we all sing.
Vande Mataram, Vande Mataram, Sujalam Sufalam, Malayajasitalam, Sasya Syamalam Mataram, Vande Mataram. Suprajyosna pulakitayaminim pullakusumita drumadala sobhinim suhasinim sumadhura bhashinim sukhadam varadam mataram vande mataram. Vande Mataram, Vande Mataram. धन्यवाद. नमस्कार.
Dhanyavadaha, Babuji. Now we'll start with Prarthana. Shuklam Bhardharam Vishnu Sasivarnam Chaturbhujam Prasannavadhanam Dhyaye Sarva Vignopasantaye. Okay, let us start with the session. We all know Gautam ji, no introduction required. Today is the second day of the series of lectures we are having. We are into the second month, and I hope you all have been revising the topics which are covered in the first month. And I suggest you start with remembering the names of the topics which are covered during the first month, and then further go down in each topic what all things you have learned. So one of these days we may ask what are the topics which you have covered in one sequence. Probably you all should be able to say in Sanaatana Dharma we have learned 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then next in each topic what all highlights we have are there, that also you should be able to tell as a next step. And all these things will be in the examination which you are going to have at the end of this month. It will be a multiple choice question, and you have to select a right answer. So therefore, I request all of you to revise our syllabus topics, and then what is taught, go through the recordings. Thank you. I request Gautam ji to continue his lectures.
Namaskar. Namaskar. Welcome to all of you, all participants. I was discussing here in this particular, I was in this slide, but the general multiplication using the Tirjag, actually full name is Urdhva Tirjagabdham. Urdhva Tirjagabdham. That means that in the upper left you do that, it is Tirjag. 4 into 5. First you do 3 into 5. on the right, and then you do 4 into 5 plus 3 into 2, and then on the left you do 4 into 8. So it is shown here. So it becomes that, and whatever carry is there, you write it down, and you get that. After adding, it becomes answer. It actually, I was thinking, it was actually different grouping of what we conventionally see. In our case, it becomes first we do everything with one particular number, say 43 multiplied by 5. So we do it 10a plus b into c we do, d we do on the top, and so it becomes 10a d plus bd. Likewise, group is different. Here the grouping is different. That is the only difference. Did you practice some of any of you practice this one? So here it is the length, because length is again increased, so it actually increases to your again there will be more combinations that we have shown by arrows, putting the arrows. So you just understand how it comes, and accordingly the length of the result also will increase. So similarly, when it becomes 5 into 5, it becomes very long. You cannot know. So here, I just the same example, namely this 2, 3, 4, 3, 1 into multiplied by 3, 5, 6, 4, 2. I split it. You just try to understand. I purposefully put some gaps on the top, and so it actually becomes very easy to understand how it actually it is happening. Here 2 into 3 is 6, and 2 into 5 plus 3 into 3 is 19. So 9 here and 1 here, because 19 carry is actually should go below 6, below slightly left. Similarly, this 39 comes from 2 into 6 plus 4 into 3 plus 3 into 5. This kind of Tirjaka Dharma. And this one in the middle of 5, this comes actually 55. This into 2 into 4, 3 into 3, 3 into 6, 4 into 5. So likewise, if one practices, this will go actually like this. So in gaps means it is on even numbers, and in the below it actually it becomes odd numbers of such members, and all the carries are put here. Finally, it is added. Now, same thing I could have done like this. So the 6 is there. Sorry, I could have in this 56. I could have written 356. I could have written 4 and 4 and 4 in Vinkulam. So it becomes you see that it becomes easier because of this minus, certain things gets cancelled, and finally arrive at this, and finally we, after clearing the Vinkulam, we get it like this. Is it clear?
Sir, can you show how you have done the multiplication, sir, and what is the answer? Have you got that answer a little, we see the numbers, but how could you get that answer? Yeah, that if you can also explain or show us on this one, it would be great. First time, we will understand how you have done the multiplication.
Oh. Yeah, you see that whole thing?
If you can go through 2 digits and 3 digits, I think.
Yeah. So it is like this, right. For 2 digits, the expression algebra is there in the top. Any number, say 43, it becomes 10 into 4 plus 3. And 25 actually 10 into 2 plus 5. In algebraic expression, I cannot say that say A is equal to 4, B is equal to 3, and AB is 43. I cannot express like this, because AB means A into B. So this is our decimal system or the place value system, where this A is equal to 4 is written here on the left, means actually 10 into A. plus B plus 3. So actually, suppose given two numbers A and B, I have to construct a, they're all digits. I have to write a number like 43. I have to express it like this. 10A plus B actually becomes 43. Will become 43. So similarly, this also can be expressed in this like. So C is 5 and C is 2 and D is 5. So 10C plus D. When I multiply these two, I find that it becomes 100 into AC plus 10 into AD plus BC. Here this is Tirjagabha. This is actually Tirjagabha. These are straight, B into D. The last one is last one. This is first one with AC means first one with first one. And this is the cross. First one of the top with second one in the bottom, AD. And the plus first one, second one of the top into first one of the bottom. So this becomes the cross. So here by arrows it is given here. So 4 into 2 is here 8, and it becomes 4 into 5 plus 3 into 3, 2 is equal to 26. This cross is 26, 2 I write below, and right is 3 into 5 is 15. So it becomes like this. So finally I add all the carries, 5 and 6 plus 1 is 7, 8 plus 2 is 10. So this is the thing. When you increase it, it becomes like this. So any number, say 314, I can express it in this way: 100A, 10B plus C. This is a Ekai Dahai Satkara, means unit 10, 100, this way. So that is that when we multiply, it becomes this much. Because of the last will become this 10,000. In 100 digits, 100 into 100 becomes 10,000. So any that 3 digit becomes 5 digit. And obviously it becomes more, so it becomes 6 digits also. So likewise, it shows that these are the small between 1, 2 and 4, 5. This one. I mean, this is 1, 2 into 4, 5. This becomes all encompassing. This is the highest term. AR plus BQ plus CP. This is the term. So even these are placed and carries are placed here. And so you understand this thing? It says cross symbols. Anybody any problem understanding?
I mean, now it's clear. On only thing is you'll have to practice. I mean,
3 into 3.
Yeah.
3 into 5 plus 3 into 1.
Right.
3 into 2. The first extreme left versus extreme right. And on the again extreme right versus extreme left, and middle versus middle. See?
And only the carry that is to be remembered. 4 3 is 12. So you write 2 and put 1 down.
Exactly.
Okay.
This 8 right here, I write 1 down. Because it will be added to the left one. No, it is at more 10, it becomes 10 10's value more.
Right.
It will go towards left.
No, but with this much of this thing, is normal multiplication not simpler than this?
Grouping is different, so you can try, but here I'll compare these things.
No, in the sense, what is the real advantage? Because too much of grouping, then adding here and there. Otherwise, simple multiplication, I feel I can do faster than this.
Is it? Okay. So it becomes a different choice. I'll give it finally. So this is the
where do we resort to this? Where does the advantage come?
See, advantage comes. See, different methods I have put here. This is the Tirjagabham. But using, see, this is not using vinculum and this is using vinculum. See, using vinculum, it will be easier.
So can you compare conventional mathematics versus Vedic mathematics? Mathematics will give advantage. If you say, then people will be more enthused. Otherwise,
yes.
More complicated only.
First, let us learn Vedic mathematics, then we will compare.
Yeah.
Excuse me, sir.
No
These examples were not given in the book that was presented in the group. These are somewhat different PPTs.
Yeah. Actually,
The book that was given in the group, these examples we cannot find so that we can practice.
Yeah, right. Actually, you are telling. So I have my own examples.
Where is the point in practicing in that book that has been presented in the group when it is a different problems that we are learning in the class?
You want me to share this this presentation as well?
Yes. That will be better, because that book has been an extract from that main book that you have referred. And that's the reason there are no your examples. These are your own examples. And I think
where is the point in having that book with us so that we can practice whatever you are teaching in the
this for
class?
Learning.
No, the practice must be there for mathematics.
Yeah, you're right. Anyway. So you want me to share this this presentation also?
Right.
I am taking screenshots from your PPTs and I am practicing. That is okay.
But you share this PPT, that will be fine.
Sir, the main purpose is we have to learn and practice the Vedic mathematics. Simply you are telling is not, the purpose is not being served.
So where you are feeling difficulty?
In practicing.
Actually, I want to be practiced, sir. Mathematics means practice. Number of problems we have to do it, we have to learn. Yeah, you please give us some exercises so that we can practice. First, we have to understand your PPTs, and they see there are so many multiplications, rightmost, leftmost, middles, all these things we have to do, is it not?
Yeah. You are right.
So maybe you can give us one assignment after the whole thing is over, which we will do.
Yes. Certainly we'll do it. So you followed that particular book or the screenshot you are given, or not screenshot? I mean, one book was shared through some time back.
Yeah, we are going through that. But then whatever you are explaining through this present class, you share this.
So can you show me that anything in understanding problem was there, and can you tell the exact problem that you want to discuss?
The problem is only doing exercises, nothing else.
Sir, please continue with the session.
Right. We will solve this problem later.
Right.
So actually, this is I was finding this. If the numbers are very high like this, it becomes difficult. So actually,
sir, I humbly submit, sir. I humbly submit that your teaching is very good. You are all teachers, but we are laymen. Vedic mathematics we do not know, so we must practice. Yeah. Please understand our problem. Simply you are going teaching, okay, but unless we practice, how can we understand the formulae?
Badri Garu.
Sir.
Hello. You made the point, he has understood. Let us go ahead. He'll give one method, and based on that, he will suggest an exercise.
In the conventional method, if you do like this, you'll find that when I was telling, but it looks very,
Gautamji, you go whatever you have planned. Otherwise,
some time will be, because we have limited time. We only 5 days, and it's very that way.
They have given their suggestions, but whatever you.
So I give you an exercise. You do it in conventional method using like this. You multiply. What is the mental exercise for doing so? And the same conventional method you try, not the Urdu Trijabgabham. You write the conventional method by using Vinkulam. You see that what is the any advantage you get or not. I give you this exercise. Kindly make the screenshot or note it down. See, I express this 8, 8, 9 into like this in Vinkulam notation, and similarly 898 also is converted into vinculum notation. And you please multiply in the conventional multiply and vinculum multiplication. You do the compare, and then you compare with these three also. You just make a screenshot of this, and then see here. You see that since the numbers are very big here, it is better to do in vinculum. It becomes advantage. But Nikhilam actually, it is quite near to a power of 10. So this becomes even easier here. Whereas only this one you have to do separately. You are calculating this and you are putting this 1, 1. These are carry and 322 is here. So finally the answer becomes obviously same for everything. Okay, so this multiplication you can again go back or you can practice and you can tell me, I mean, afterwards, you feeling difficulty. Today, let us go to another new topic. And because we have to, the syllabus is there and the days are 5 only. So this is the division. This particular division here will be limited, not go beyond finding a quotient and remainder. The purpose of division is to find quotient and remainder for any given dividend and divisor. So dividend is 34 here, and we are dividing by 9. Division by 9. Vinculum is 1. So 1 I can write, or sometimes you do not write like this. 3, 4. This thing is that 1 multiplied by 3 is 3, and this goes below, and this answer becomes 3 and 7. 3 will be the quotient, and 7 will be remainder, as easy as that. You are not making the actual division. You are only what you are doing. You are multiplying this 1 with 6 and putting it below 6, and adding it with the already given, having remainder. Adding a total, you are getting 7. You can see 12. Here also it becomes like this. Here it becomes 12. So it becomes.
Sir, can you tell? Sir, actually not able to understand the division thing. Tell once again, please.
The rule is that the 3 multiplied by 1. 3, and this will be put below the remainder. If it is 1
we
digit
are
only,
dividing 34 by 9, sir.
So you see that immediately you get the answer that the quotient is 3 and remainder is 7. The other way you do, you see that 3 is 27 and plus 7 is 34. Actually, this is the division line between the quotient and remainder. I mean, quotient and remainder in this case. Here we divide it to have that clear understanding that this will go to the remainder part.
The 34 means, why did you write 3/4?
3/4 actually, that as I told, that it is probably potentially it is towards remainder side, so it goes to remainder side. It is like that. If you divide 34 by 10, we get 3 and 4. 3 is quotient and 4 is remainder. So here what happens, because the 1 is the deficient, 9 is deficient from 10 by 1. So we get that 3 gets added here, and it becomes 7. That is the idea.
Okay. This is division by 9.
Division by 9. 1 to 23, it becomes 1 and 3, and 13 and 6.
So, sir, in the first case, it is like 1 goes 3 times into 3. So that is why we are doing it by 3. And then we will add 4 and 3, so it will give 7.
And here it is 2 digits, it becomes different. See, 1 comes here, 1. But 1 plus 2 is 3, so this 3 comes here. And eventually it becomes 2 plus 1 again becomes 13 here, 12 plus 1, and 3 plus 3 becomes 6. We take another example, it is slightly complicated. I mean, it becomes 2 steps, one more extra steps is required. 253 divided by 9. Actually, again, this 1 is there in the, because it is 1 is a vinculum. So 1 into 2 becomes 2 here. Then 5 plus 2 is 7, and 1 into that 7 becomes 7. You have to write in the remainder portion. So initially it becomes 27, and then 10. But 10 is again more than 9. So again I divide 10. So again I put a slash here, it's quotient and remainder like. And this 1 gets added to this 1. I mean, and this particular one gets another, because if I divide 10, the quotient becomes 1 and remainder becomes 1. That quotient actually add to this quotient taken earlier, means becomes 27 to become 28, and this will become 1. The 1 will remain as 1. It's clear?
Only what happens to the middle one? I mean, you just ignore it.
Oh, no. This
26
1 I put here. 1, it is on the quotient side. So it must add.
Okay.
And actually, I one step I jumped actually. It has to be written 27/10. 10 I again split. 10 I immediately split it, because 10 is more than 9. I have to immediately split it again. So this 1 becomes the quotient is added to the earlier obtained quotient. And this finally, out of 10, 1 remains. Obviously, 10 is quotient, remainder is 1. Okay. So, and quotient is 1, remainder is 1, that is 10 for 9. Because finally it becomes 28. 1.
Yeah.
Yeah.
Okay. One more example can you have?
Yeah. More examples.
In this case, vinculum is always 1, na?
In case of 9, obviously it is vinculum is 1.
Okay.
10 minus 9, 1.
Division of 9, we are not writing in, we are not writing in vertical columns. Rather, what we are doing, we are writing in, adding directly. See, 1, so first is 1, then 1 plus 2 is 3. Obviously, it becomes 3. 1 plus 2 plus 3. In fact, it is already 1 plus 2 is there. So 3 plus 3 is 6. And 1 plus 6 is 7. So finally it becomes 1367. And this remainder is 9. Again, if 9 means it becomes add 2. You don't have to do any division for that, because 9 means we know that it becomes 0 and quotient is 1 quotient side is added. 1368. How quick division you see? Basically, we are unnecessarily not dividing by 9. What we are doing? We are seeing that had it been divided by this 1, 2, 3, 1, 2, had it been divided by 10, we could have gotten 1, 2, 3, 1 as quotient and 2 as remainder. But 9 is 1 deficient from 1. So in every 1000, we get one more 100. Every that 1000 plus, this becomes the new 100. And in every 100, we get 1 more 10. So this is the 3. And every 10, this becomes a new 10, becomes this one. And every 10, we get another unit digit, more unit digit. So that is the logic of dividing this way. And finally, remainder also like this. And so it gets like this. Here, so it doesn't matter how long it is, you keep on doing like this. Only thing is, problem is that if it's bigger number, you have to practice is more, and there will be carries and so on. That is
Sir, in the first example from 1367/9, how is that last this thing derived?
Because 9 remainder. Something dividing quotient is 1367 and remainder is 9. In case of why we are dividing by 9, can this remainder be 9? We cannot tell. Immediately it will be divided once more. So it will be add one more quotient will be there, and then remainder will be 0, isn't it?
Oh, right, sir. Right.
For dividing by 9, it can be remainder can be from 1 to 0 to 8 only. 0 means it is dividing, perfectly dividing. No remainder, and 1 to 9 can be remainder depending.
Okay, fine, sir. Thank
you. So this way also 1, 1 comes here. 1 plus 2, 3. 3 plus 0, 3. 3 plus 0, 3. 3 plus 2 is 5. 5 plus 1 is 6. And finally, we add these also, because these are the contribution from, had it been divided by 10. And this is the contribution from that deficient one when we are dividing by 9. So this is, we have to, we are adding finally these, both the things. And the
top 2 is what? 120021 by 2. That 2, how
no, by 2, this is not by 2. Actually, total number was 1200212.
Oh.
So first, what we are doing, had it been divided by 10, we would have gotten this as this is quotient and this has been remainder. But if I had divided by 10, and but we are dividing by not by 10 but by 9. So what is the deficiency of 9? So therefore adding to something more quotient you are getting. So we keep on writing for every 10,000, every lakh how much, every 10,000 how much, every this way. Keep on adding these things.
So the last digit is to be separately written.
Last what?
Last digit is to be written separately.
Yeah. Yes. So that is the procedure. Here also it is like this. Here it becomes 4 plus 9 becomes 13. You write 13 here. Don't put 1 here because this is not dividing by 10, it is dividing by 9. So you cannot, this 13 is not actually, it cannot write, add 1 here and put 3 here because you are dividing by 9. So you have to finally divide by 9 only. So this becomes this quotient and remainder. And but 2, again 22 have to write. So because 2 into, this 2 comes here, 2 and 4. So this, this 3 is added to this 2 and becomes, the quotient becomes 112305. Oh, sorry, it should be 405. No? Typing error. So it is like this. And quotient becomes 4. Dividing by 8, 7, and 6. So in case of 8, it is vinculum is 2. So here see, it is dividing by 10. 23 is being divided by 10. So 2 becomes quotient and 3 is remainder. But we are dividing by 2. So in every 10, there will be the deficiency by 2. So because 2 into 2 becomes 4. So finally this becomes 7 becomes 7 remains remainder. Had it been divided by 9, would have been I mean it becomes 5. So with dividing by 10, it becomes 3 remainder. Dividing by 9, it will become 5, and dividing by 8, it becomes 7. So this way you have to consider. Every 10, we are deficiencies by 2. 3 by, or deficiency become an advantage actually. 3 and 1, so it becomes 3 into 2 becomes 6, so it becomes 3 and 6. In case of 7, this it is 3, so it will multiply by 3. It becomes like this. So this is about 1 digit, and this can be extended to more digits, like 234 by 8. So 23 and 4 in case of 10, but in case of 2, it becomes 2 into 2, so it becomes 4. It becomes 7. 7 in the unit digit. That 7 in unit digit, because of 2 deficiencies there, it will add to 14 in the remainder. And 14 plus 4, it becomes 18. And so it becomes 27. But again, within 27, it will go to twice. It could have done again written separately, 2 and 7, like this I could have written. So finally it becomes 2 more are there. Oh no, it is 18, sorry, 18. So 27 and 18. So 18 is remainder. Within 18 remainder, I get again 2 2 into 2, I mean 16. For 16 we get this becomes 29, and then 2 becomes remainder. 3, 4, 5 by 8. This becomes again 2 into 3 is 6, and 4 plus 6 is 10, and 2 into 10 is 20. Becomes 25 and 40. So 25 actually contributes more, 3 more towards quotient. I could have written by like this 2 and 5. It would have been same result, and it comes 3 and 1. So 43 becomes 43 and 1. So you just think about it. I think it will be clear.
Namaste, Gautam ji.
Namaste.
This second row of problems are there. No? This 14. How did you arrive at the 14? Okay, will you please in this year?
Oh, 3 plus 4 is 7, and 7 into 2 is 14.
Okay. Okay.
So every unit digit, the deficiency of 8 is 2, so it becomes twice of that. So it will contribute to the remainder.
Okay. Okay. Yeah.
Sir,
Thank you.
in the first row, when we are dividing 23 by 8, that is the first one. We are saying 2 into 2, 4, and we are writing 4 below the last digit. But just the example which is just below that, there we are writing that 4, 2 into 2, 4, the second digit.
Which one? Which one?
So 1 second. Sorry, actually, the power of this thing was going down. So, sir, what I'm saying is, in the first example, when we are dividing
23 by
8, so we say 2 into 2, 4, and we write 4 below the last digit. But the example which is just written below that, here we are saying 2 into 2, 4, but we are writing this, 2 into 2, 4, but we are not writing this 4 below the last 4.
Oh, no. You have to write to the next one, because see, it is the hundredths digit, and its deficiency of 2 is in tens. So it becomes, this will be tens.
Okay.
Every
time we have to write
the next one.
Okay.
So here, now it is 3 plus 4 is 7. And when you multiply with 2, this becomes 7. It's because there is no further unit digit. So it is thrown in the remainder side. It will contribute to the remainder. That is the idea.
Sorry. You are saying that when we say 2 into 2, 4,
from tens digit, it becomes to given to a unit digit. But
right.
There is no further unit digit, so it will be thrown towards the remainder side.
There is no further unit digit. But sir, when we say 2 into 2...
No. I mean, no further unit digit, not that, because it is no further unit digit if we divide it by 10. So
okay.
Here I'm telling.
Here there is no, in 23 there is no further unit digit. Okay.
Yes, that's what I'm telling.
Okay.
On the left side of this oblique.
Right. Okay.
To this.
Okay. Sir, can you go back to, one slide back there?
This one.
Yeah, this one.
Yeah.
Sorry, sir.
9.
Yeah, this one. So, sir, in the middle example, we are saying...
Now, here actually, I could have written out below, I could have written. But in case of 9, this becomes very simple. There is no carry. So he kept on writing like this.
Right.
So this is for ease of use actually, or nothing else.
Okay. So
I could have written below like this. Actually, there should be written below. This is actually in shortcut, you can say. Writing like this way is shortcut. Actually, it should have been like this, below and below like this.
Okay.
I think in the start you keep writing all the steps because shortcuts you will understand. We are the beginners. Right.
So yes, in the book also it is written like this. But I deciphered from there. It's nothing different. It is only that since it is what is the point in writing below? When I can write in, I can see that is 1 and 1 plus 2 is 3, 3 plus 2 is 3 plus 3 is 6, 6 plus 1 is 7. I can show transparent. I can see here. Why to write unnecessarily below and then it will look like all vacuums, gaps like this. Large gaps will be there on the left. It is not very looking good. So therefore, in case of, especially in case of 9, in case of 8,
here
it will be unmanageable.
So sir, here in the second example, when we are dividing 1,2,0,0,2,1,2 by 9, we are saying we are doing 1 into 1, then it becomes 1. Then 1 plus 2 is 3, and 3 plus 0 is 0. Oh, 3, 3. 3 plus 0 is again 3. 3 plus 2 is 5. 5 plus 1 is 6. Okay. So sir, how are we doing this same thing in that next slide? If you see, if you take the last, I mean the first, second, this thing, this one. This
4
one.
plus 3 is 14. 4 plus 3 into 2 is 14. We're doing the same thing.
So 2 into 2 is 4. That is okay.
4. Okay.
Then we should have added 4 with 3, right, sir?
4 with 3, I will add 7. 7 into 2 because it is.
We have to multiply 2 also. Okay.
Yes. Because here we are multiplying with 1. So
we are not feeling that anything is happening.
We are not feeling that something you are doing. We are just putting it. That's all.
Understood.
And here we are multiplying by 2. In case of 7, you have to multiply by 3. In case of 6, you have to multiply by 4.
Right.
In case of more than less than 6, it will not be vincula. This method will not be efficient. That is what is called.
Right, sir. Thank you, sir. Thank you. Now I have understood. Thank you so much, sir.
Okay. Anybody else? Anyone else?
Yeah, it looks very fine at this moment. But when you give an exam question, I don't. We may struggle in between.
No problem. Actually, in numbers of in first go actually very easy because it is a change of mindset. You can say.
Right.
This mechanically, if you understand, I also it is not given in the book. I thought it over that why it is like this. Had it been divided by 10, this would have been the result. Q and R. Now every 1,000 we are advancing by again this many numbers of 10, this many numbers of for in case of 9. Every 100 we are getting more advantage for this deficiency of 1. So that is being that every 1,000 we are getting 100 more. Isn't it? Because 10 into 10 and in case of 9, we get 9 into 11 is equal to 100, isn't it? So in every 100, we are getting one advantage of 9 extra. So that is this one. 11 into 9 is 100, or say 999. 1,011 into 9 is 999. Whereas 100 into 10 is 1,000. So every 100, every 1,000, every 10, every 1,000, every 100, every 10, we are getting one advantage. So that we are putting it here. Okay. So that is the idea. So this is the thing. And next I go by division by 2 digits.
Oh,
actually, this has become slightly, you imagine a cross, but I mean, these are 5 problems in one row. I could have separated it. It would have been better. Maybe that I will separate tomorrow. It will take some time. It is like this. 111 is getting divided by 89. So vinculum is 11. So here you 1 into 11 we put here in the remainder. It goes to becomes 1 and 23. If we divide 111 by 100, it becomes 1 and 11. Whereas the 11 is shortfall. 11 more remainder we get. So that remainder is added here and becomes 122. In case of 222 divided by 87, for example, 13 is the deficiency, vinculum of that. So because of the 13, in 200, we get that 13 gets added into remainder. So it becomes 26. So it becomes total remainder. Earlier it was 22, had it been divided by 100. So that 22 gets added to that, it becomes 48. 333 divided by 88, 12 into 3 becomes 36. It is added to the remainder and it becomes like this. So 888, here there is, we are showing here that where there is no contribution to the quotient, but only remainder is getting contributed. Only how the remainder is to understand the concept that in 888, 112 is the deficiency from 1000, where 1000 could have given 1% and 234 remainder. This, where this 122 12 will go, that will go to the contribute to the remainder, and the remainder will become like this. So it is easily that by the concept, we are actually not giving any table, we are not multiply 7, 8, 9, all these large numbers.
Right.
We are only looking at the deficiency.
Right.
How much it is deficient from 1000. And
Right.
it can go to any number, any say 5-digit number divided by 4-digit number, immediately you find the deficiency, and it is actually general number. You could have increased it to any level, and one less you could have increased, and the formula will be same. Unnecessarily, you don't have to do the conventional mathematics. It will be unnecessarily you are overdoing the things, isn't it? What do you think?
Yes, this particular example.
It is just a mathematical mindset.
Right.
That basically what you are doing, we are following the deficiency.
Right.
And the deficiency is contributed either to the quotient or remainder, depending upon the situation.
This particular method of 2 digits, 3 digits makes it very clear that how advantageous it is to have Vedic mathematics. And here I have a small observation that when you have 2-digit division, then you take 2 digits after the, for example, 333 is there, and you are dividing by 88.
Yes.
So you put 2 digits on the left.
Right. Why it is so? You tell me. Because this top number we are getting, it is the nearest 10's power.
Right.
Nearest 10's power. Had it been divided by 100, what would it happen? Had it been, this is the closest 10's power is 1000. Had it been divided by 1000, what would have happened? Quotient and remainder.
Good.
This is the deficiency, and deficiency we are putting, and it becomes advantage to we are getting extra more remainder. That is the idea. The mathematics behind this, you are thinking it. So therefore, you are getting it clearly. Now it becomes complicated in the next slide.
Okay.
See, 11 you are multiplied by 89. Okay. So 11, this had it been divided by again 100, becomes 11 and 11 quotient, 11 remainder. Now it is this 11. How this 11 will come? It will contribute one in the unit digit and 1 in the remainder first to start with. One not only remainder, in the 10th digit of the remainder it will contribute, not here. So therefore it is written only as if it is invisible 0 is here actually. It is 10 actually.
Okay. And
in the next one, this becomes, because this 1 more is added towards unit digits, it becomes actually 1 plus 1. But the whole thing becomes 12 actually. This because this 1 plus 1, again this multiplied by 1 and it contribute to 22 towards remainder. And this actually is 1, not 1, it's 10. So therefore we multiply 1 plus 3 is 3. 1 plus 1 plus 2 is 4. And this becomes 11 plus 1. Obviously, it is contributing 1 to this quotient. So it becomes, total quotient becomes 12. Like this.
Yeah.
This invisible 10, 0 we do not write actually, but it is actually there.
Yeah. And just like in normal multiplication also, that 0 is there, we don't write.
But here also we do not write the 0 in that right.
Right. You have to place it properly.
Normal thing, you do not write 0 in the left, but here in this particular, remember actually this, we have to remember that this comes below this. Means there is a 0 also.
Right.
Here in case of slightly bigger you do, here actually it becomes it's multiple processing, bigger and multiple processing. So even doing so, you'll find that you are doing tables of 7, 8, 9. This will be even then it will be easier. I think. Now once you practice it, you are dividing it by, so it becomes actually this 21,000. So it becomes dividing by 1,000. These 21456. Remainder would have been 456 and quotient would have been 2 and 1, but it's 211 is deficient. And then multiplied by 2, it becomes 422. 4 will contribute to the quotient and 22, actually 2 to 0 will contribute towards remainder.
Okay.
And 1 plus 4 becomes unit digits, and this total deficiency of this multiplied by this will multiply here, and it will all contribute towards the remainder.
Here a small doubt.
Actually, it is not properly aligned because this 1055, 5 will be the unit digit. Actually, it could have been written, slightly.
Right. I mean, slightly shifted.
With practitioners, if they did properly after practice, it will be clear.
Right.
Actually, it should be like this. It will add to this particular thing. Okay.
I have a small doubt on this 21456 divided by 789. On the second step, when you have 422, you have a 3-digit number. So 422 as reminder. On the second step, after 21456, you have next is 422.
Okay. What are you telling? This 4 and 22.
Right. So when it is a 3-digit number, how are you splitting it into 4 by 22, or is it should be 1 by 422 because it is 3-digit number? 3 digits should be out on after the slash.
No.
Yeah.
It is actually, this is as I told, from 21,000. There will be more contribution in case of 221. There will be 4 more contribution. It will 4 more such will be feed actually.
Right.
That's what it is.
Okay. Okay.
And 22 will be the remainder. Yes.
Sir, this 1055, how is it arrived?
This becomes 1 plus 4 is
5.
5, and 5 into 211 is 105.
Sir, can you explain once again how did you get this 4 first of all?
This 4 this 4. 221 into 2, 4 and 22. 4 will contribute towards quotient and 22 will towards remainder.
Okay. Kindly share this PPT with this particular example.
This PPT, yes, I request. I will send it again in this Sanaatana Dharma group. I'll send.
Right.
Are you members of the Sanaatana Dharma group as well?
Yeah. I mean, this particular course group is there.
And in this course, because in the course actually it is, we don't have rights permission. I cannot send directly. So
you can send it to Kalnan Saab and Babuji, and he will post it.
Yes. He'll post it.
No, probably this example with arrows. Which one is getting multiplied with what? That arrows.
Yeah, the first one.
Oh, no. What I have shown here, see, it becomes 1731, which is more than 789. So I have to again divide it. That is the problem in this.
No. This process by multiplication or addition, you put the arrows and share.
Which one? Oh, no.
No,
this
this
is
example, you put the arrows where that multiplication or something is happening because it is not visible. No? You have shown some arrows in the earlier method. Which one is getting digit to digit arrow?
yeah, but here there is no scope of writing arrows actually. What is the scope?
Gautam ji, ऐसा है. I mean, you have earlier shown that example with arrows.
That is in case of multiplication.
Right.
Urdu
So,
Tirjagabham. How
right.
this Tirjag is multiplying, that we have shown.
Right. So similarly, in one of the examples, if you can show as you proceed, one example, if you show, we can understand more better that the arrows, so that it becomes easier. That's what he means. The same way that you have explained earlier.
Oh. You mean to say something like this one?
Ah, yeah. Right.
Something like this one.
Right. You have to, I think, do some exercise.
These are all arrows. Are you just you put a mental arrow there. It will go to this way, below and down.
Right.
Okay. This becomes.
Only thing is, once we do some few examples, we will automatically get it. Before in the start, there is a problem. That's it. Nothing else. Okay, go ahead. I think.
So actually, like this. So let me explain this here more. So remainder in the first go, remainder becomes 1731, which is more than 789. So what to do? Once again we divide 1731 by 789 and get this two. This is 1, so it is 211 and it becomes 942. Okay, but again 942 it cannot be divided that way. You just simply minus, subtract. 942 is subtract, this 799 is subtracted from 942, becomes one more it contributes, and so becomes quotient becomes 2 and remainder 153, and finally this 2 quotient contributes to the original 25 quotients here and becomes 27 quotient and 153 remainder. Okay.
Right. Okay.
Clear?
Right.
Again another question, another example, slightly bigger. 121 121456 divided by 789. Again by 1000, if we divide, it will become this quotient and this remainder. We separate it. In 200, the 211 becomes 21. It gets advantage towards this quotient, and 1 means 100 actually towards the remainder. Again in the next step, this 2 plus 2 is 4. 4 into, we will again multiplied by 4, 844. And this 844 actually it becomes 44 is the contribution towards remainder. So 4 plus, actually it is slightly shifted here. It is sometimes it may be a little bit confused here, I think.
So please repeat, how do we divide 844, like 8 to the first part and 44 to the second part, and in the first one 211, like 21 to the first part and 1 to the second part?
Oh, it is actually when you reach towards unit digit, after that everything gets contributed towards remainder. It doesn't go contribute anywhere to here. So that is the thing you have to see. You have to consider that how much you are doing in what situation.
Okay.
When finally you reach to the so this actually, this will practice, it will come that what to what is contributing where. Here it becomes 44 is the remainder. Here it was 100 was remainder here. Here 44 was remainder. So remainder will gradually go towards the unit digit actually. So This 4 plus 6 is plus 6 is. Oh, no. I'm sorry. It was right, correct. Like this. I'm sorry, it is 440. So it becomes 6, 5 plus 4 plus 1, 0, and 4 plus 1 becomes 2 becomes 3 here. Yes. It was correct, yes. I unnecessarily wanted to. And now again, the 3106 is yeah. Yeah, because it was still it was three digits is here, 3 digits are here. So when yes, I was wrong, because it is it will contribute towards this one. It will contribute towards 100 digits of this. This will contribute towards also on the, because it is a unique digit, and now this is the full remainder. This will become full remainder, and it will go up to the unique digits of remainder. That is the thing. You have to understand like this. So therefore, it becomes 440 actually. This becomes 100. This becomes 440, and we add up here 3106. And this 3106, we again do it, and 633 and 739. So it becomes contribute towards 3 gets contributed towards quotient, and 153739. We take another example where these 3 steps will be required. 2, 3, 1, 4, 5, 6, 2, 11. Here it becomes 42 becomes multiplied 2. 42 contributes to our quotient, and 200 is towards remainder. Again, it is 14 here. Because it is becoming larger and getting more complicated. 3 plus 4 is 7. 7 multiplied with this one, 14. But this will be totally contributing. I will shift slightly. I will shift it. Yes, it looks like this. It becomes actually 777. Yeah. Because of some reason, actually, it gets shifted. So all this must align actually. All these things, because of some font change and so on, it got shifted sometimes.
This alignment of lines is very important.
Alignment of this line, the division between quotient and remainder, quotient side and remainder side. Earlier, had it been divided by 1000, it had been the quotient and remainder. Now, because there is 211 deficiency, you have to think always like this. So we get more contribution towards quotient and remainder. So that is the thing, and 422. So, and finally becomes, actually is 7 plus, this 3 plus 4 is 7, and multiplied by 211 is 14. So 14 I cannot write back towards this one. I could have actually separated. So actually, so 14, no problem. 14 will contribute towards 10 digit of this one, no problem. In case of remainder, it becomes problem actually, because what we have to write, think of what actually 200. This is actually 777, 770, and this is 3587. So 6 plus 7 is 3. 5 plus this 7 plus 8
plus 1.
Plus 1 is 1.
2.
And 4 plus 2 plus 7 plus 5 is this. Okay, plus this thing carry was there, and 2 was carrying, 3 plus 2 is becomes 5. So this is the thing, and again 5013, again you do this thing, multiply by 5, 10055. This everything gets contributed towards remainder, and this actually 5 gets added to 8. This comes in practice, what we'll add, because it is actually 1055 total. So it is this is the unique digit of remainder. So this way you have to do. Again 1060, because it is more than 789. So you again do it, and finally you get 279 and 1. This 1 plus 5 plus 1 added towards 287 becomes 293, and remainder is 279.
Oh, okay. Okay.
So from 287 plus 5,
Plus 1.
292 plus 1, this one.
Yeah.
In every step, we are getting this. We are
Hmm.
giving, we are again further complicating it, because you see finally that the Nikilam method is called, more you reach towards 555 or smaller numbers, it gets more complicated, because you get more this vernacular, you get more, and as a result you get bigger and bigger remainder, and you see it is dividing by 654, but remainder we are getting 1900 799 in this method.
Hmm.
So
Sir, excuse me, sir.
huh?
Sir, can you please go back once to the previous slide?
This one?
Sir, here in the second row, on the first example, 121456 by 789.
121456.
Yeah, right, sir. So,
Yeah.
sir, what I was asking, like here we did 211 into 1, so it became 211. Then adding 21 to 1, it becomes
No. 2
Huh.
plus 2 is 4.
Oh, like that.
Yeah.
2 plus 2, 4, and 1 plus 1, like that. No.
2 plus 2 is no. 2
Okay.
plus 2 is 4. So I have to write now, I have to find that because from that 211, there is one more 21 contribution from the, because of this, over and above the quotient would have gotten by dividing by 1000. So we have gotten this again to one more contribution like this to 21. So in the that unit digits of the 10th digit, we are we total 10 digit we get 40. Okay, 4. So this 40 will contribute here and will contribute 800. And then the 8 plus 1 is 10. And this 2111 into 10 is 2110. Finally, this will contribute towards remainder fully. Because we have here we had reached in the unit digit, no further no further contribution initially from the quotient side. Whatever remainder you want to find from remainder, you have to again do the same exercise, and then only find that how much. I cannot directly contribute this 2 towards right towards quotient, because this is not by 1000. You are dividing by now 789. That we have to take in mind.
Okay, 3106 and
okay, thank you, sir.
This adding this 3106 again 3106 I do, this becomes like this,
53,
and you add this quotient to this quotient.
Okay.
Okay, so this 3106 has further contribution from dividing by 1789. So it contributes 3 towards quotient and 739 towards remainder. 739 becomes less than 789. We will leave it like this. Here it in 2 steps. Here another example I was telling. This is actually requires 4 steps total. So therefore, so this is just for giving. We don't will not cover it here. You just make you screenshot in practice. But once you understand the concept, it will go again. So it becomes 492 plus 22 coming from here, plus 5 coming from here, plus 2 coming, 3 coming from here. But 2 came from here, but again, it is more than this 654. You simply, in the last step, simply, it is the same number of digits. You cannot separate like this. Same number of digits, you simply subtract. By subtracting here, you get final step and you contribute 1 more towards this one quotient. You finally get total quotient is 500. Okay.
So
now I get special case here.
Yeah.
Another technique, sub-base technique. Like in multiplication, we had a sub-base concept. Here also we are getting a sub-base. So it is like this: 1011 to be multiplied by 23.
Divided by.
Sorry, divided by 23. Now, how it does it? That we have to find that how to come to near to 100. 23 multiplied by 4 is 92. It is near the power of 10. So we divide by 92. Initially, this 1011 we divided by 92. So again, you remember, had it been divided by 100, it would have been 10 is quotient and 11 as remainder. Now you are dividing by 92. So 8 is the deficiency. I put 0 and 8. So 0 is also being clear. And becomes 10 and 91. Now, since we had multiplied the divisor by 4, in the result, basically, had it been divided by 23, we could have 4 times more would have gotten. Here, by dividing by 92, we got 10 as quotient. Had we divided by 23, we would have gotten 40, isn't it? Very clear. But 91 quotient will remain same because that will not contribute towards quotient. What we suppose we multiply something, some number with the divisor. When you that divisor, using the divisor, if you divide something, some dividend here, 111. So it will be becomes 4 times. No, result becomes 4 times. Means what is 900? Because see, 10 into 92 is 920. Whereas 23 into 40 is 920, isn't it? So just match it. So becomes 40. But remainder is 91. But how to tackle this remainder 91 is more than 23. So this I just put this logic. 91 again we divided by 23. 3 times I subtract it because it is same digit. I cannot again do this procedure. I cannot do. So it becomes 22. So it becomes this 3 is contributed towards quotient, and 43 becomes the total quotient, and 22 is the remainder. Is it clear? Just to observe and try to understand.
You mean instead of after 91 minus 3 into 23, the 3 is coming because it is 1 less than 4? Is it that? You want to have something less than 91.
No, it is the normal division. You can say our division. 23
Right.
is the.
Okay.
It is our conventional division. That's all.
I see.
I told that we don't have to reject what is taught by our schools, normal things.
Right. Okay.
We don't have to reject. Whenever required, we do that. We put it. But in many cases, we find that as it is big numbers, we'll do like this. Unnecessarily, in our case, it will be working more. Here it is working, even if after so many steps, still effort will be less.
Yeah.
So here it comes like this. Is it clear?
Right.
This is a special technique.
Yeah.
Now I go to, if required, we come back to any procedure. But here is very peculiar. Actually, in the algebraic expression, I also I have to think. Maybe it is easy. There is an algebraic discussion there. I didn't go through that. I may go through that, no problem. Actually, coming through algebraic transpose. Paravarta method is called transpose and apply. How it is? 1, 2, 3, 4 divided by 1, 1, 2. It is like this. That you reject this, it will be all starting with 1 always. This will be applicable 1. If it is not starting with 1, again you do some technique. That's as I told here. You divide by here and again divide like that. This kind of techniques are there. But to start with, let us start simply with a divisor which starts with 1. And accepting that 1, all we make negative. Sort of vernacular. I could have written vernacular also, but anyway, I have written like this. This is in book also written like this.
Right.
1 and 2. Sorry, vernacular. This is 1 and 2. This is you write -1 -1 multiplied by 1. So -1 -2.
So could you please just tell it from starting once again? Like, yeah, thank you.
The divisor is 1, 1, 2. So I reject this one. So block this one. It is 1, 2, isn't it? Only 1 and 2.
Okay.
I keep it aside. I keep it aside.
Right.
Okay. So this becomes -1 and -2. And this 1 and 2 I become -1, -2. I put it to vinculum. 1, 2, 3 becomes -1, -2, -2. So this becomes -1, -2. So this 2 into 2 and -1 becomes 1. Again we multiplied by 1. This because it's 1 and multiplied by 1. 2 and again the same thing. This 2 plus 2 plus -1 becomes 1. So again 1 minus 1 and 2 again. -1, -2. So finally we add 4 minus 2 is 2. 3 minus 2 minus 2 is 0. 2 minus 1 is 1. So 11 and 0 2 becomes remainder.
Here it is peculiar that.
Very peculiar.
Yeah.
But with practice it becomes very easy.
Yeah,
and it is much easier also. At times it is much easier than the previous one also.
Right. Earlier you used to add 1 plus 2 and then you used to multiply. And now you 2 minus 1 and
basically in the very first place we are converted into vinculum
right.
in this form. And you are adding basically there also you are adding, here also you are adding basically.
But here vinculum when we add it is positive, isn't it? 112 is more 12 more than 100. So 12 becomes
12 more than 100.
Yeah. So it should be positive. Why are we taking negative? Is it because it's a remainder of 100? I mean 112 when you remove 100 you have.
It is more than, yes, it is more than 100.
Yeah.
So here you see logically it is correct. You were, had it been divided by 100, you could have gotten 12 and 34, isn't it?
Right.
Here, because it is more than 100, you will get less.
Okay.
So therefore, to start with, we are vinculum, making it vinculum.
Okay.
Sir, how do we get
-2? It is almost like same. Like it is almost like same. Yes, it is actually in fact, if you think it logically, it is actually same. Except yes, it is. You are quite right. It is actually same. Where you are changing the sign. You are applying the same
sign. Yes, sign is the problem. Difference. Yeah. Okay.
So accordingly, we will get remainder also. It will be that way less. Remainder quotient also will be less, and this way.
Sir, would you mind please repeating this, sir? This particular.
Actually, yes. Actually, this is not. I mean, it is in different notation, but it is actually almost like similar one. So I write here -1, -2, and you add this 2 minus 1 becomes 1, and again you then multiply by -2.
But sir, in the first step, when we are having 1, 1, 2, why have you written -1, -2 below that? I think I've missed that point.
Oh, I see. Acha. I'll tell you. Here, see. It is deficiency. Oh, what is that? Here it is deficient by this one. Okay. The deficiency will actually contribute positively. Therefore, it was positive. But in this case, it is more. It is 12 more than 100. So So
Yes.
basically we are writing 12 in vinculum form, becomes -1, -2. Is 12 more than
Yeah.
that? So it is
We are writing -12, sir. Are we writing -12?
-12, but we have to handle the digits particular way. So it will be -1, -2. Otherwise, it will be digit wise, digit to digit. We have to take care, no?
But to start to understand, can we understand it as -12 and then -12 into -12 into 1 is equal to -12. -12 into 1 of 1, 2, 3, 4. Then it becomes -12. Okay.
So how do we get -2, -4, -6 in the second example? The second row in the second example?
This actually, this one is like this. 3 minus 2 is 3 minus 1 is 2. You are going to multiply this by 2. So 2, 4, 6. So minus 246 it becomes, but so this is actually divided into this method is divided into no problem. You can write in by this one also. Minus 123 minus 20. You have to only mind it that what is coming to us. This slash are not given here. Actually, there should be slash.
Sorry, sir, I am not again clear. Like, how do we get -2? What is the process of getting the second step? First step is clear, but the second step is not clear.
Which one? Which one?
Sir, the second example, the second row, -2, -4, -6.
Yeah. See, 3 minus the 1 into 1, 2, 3 becomes 1, 2, 3. Okay, isn't it? But 3 plus -1 makes it 2. 2 multiplied by this becomes 2 and 2, 4, 6. Okay. What is the problem?
So in the first one, it is -1 and -2 only.
No, because the 2 minus 1 is 1. So therefore, we added earlier also, no? These two we added and multiplied with this one.
So multiplied with what?
2 minus 1. See, earlier also did. This one we did earlier, no? Here, see, here we are adding this 1, 211. 2 plus 2 is 4. Therefore, I multiplied by 4, 844. Again, 1 plus 1 plus 2, 10. Because this becomes multiplied by this one. The similar thing you are doing. Except you are writing in a vinculum notation. Oh, sorry. Excepting that we are doing in a vinculum notation. That is only thing. One, 2, 3 minus 1 is 2. 2 multiplied by -1, -2. 2 multiplied by -2. 246 basically. So this, like I can write it in a different form. Only this because the vinculum means actually your position value in each case is negative. So this we are showing explicitly is negative value, and that way you are doing 6 minus 6 becomes 0, and -4, 5 minus 3 -2. 4 minus 2 minus 2 is 0, and 13 minus 1 is 11 and 12. But actually remainder -2. This is very interesting to understand.
The last
remainder is -20. What does it mean? Remainder is -20. So this -20, this 20 will be subtracted to the original divisor. So this becomes 1103. See, we subtract this 20 from 1123 becomes 1103, and subtract 1 from this also.
But what happens to the 0 that is in between? 1 to 0.
Oh no, actually 0 to 0.
Yeah.
Nothing. Actually, it is actually
20 you have taken care. Okay, you have taken care of 0 to 0 at that point.
0 to 0. 0 to 0 is 20 basically. It means.
Right. Okay. So
Well, -20. 0 minus 2 0 means -20. So we thought that the quotient is bigger, 12, but the remainder was -2. No, it is not possible. So remainder should be actually 1103 and quotient should have been 11.
This
It
is
is
a
like
bit
this.
difficult.
Whether you write 12 into 1123, okay, minus 20. This 100, 1, 3, 4, 5, 6 is equal. Either you write like this or write same thing, 11 into 1123 plus 11, isn't it? You just write, you verify, it's just same thing. So this negative quotient means actually you have to subtract that thing from the divisor, and remainder will be bigger, but quotient you have to reduce by 1. That is the idea. This 020 is not. It is not that it is. I cannot write is say 119 earlier the figure 9. This thing I cannot do because it is actually remainder. This remainder is contributes towards 1103, 1123. So it becomes 1103. Okay. So, again, I take another example. Divide this by this. 2, 3, 4, 5, 6. Minus 2, minus 3, minus 4, minus 6. 2 into this. 3 minus 4 is minus 1. Minus 1 when I do, it becomes 2 and 3. Positive it becomes. And again, 4 minus 6 plus 2 is 0. It becomes 0. See here, particular problem is there. We add all these things. See, 6 plus 0, 5 plus 3 plus is 8, 4 minus 6 plus 2, 0, 3 minus 4 is minus 1, and 2. So this vinculum notation, see, this is actually the dividing line between quotient and remainder. Actually, it is not shown here. So 2 and 1 in vinculum notation becomes 190. And it is. Clear?
Again, my doubt is same. Like, how do we get the second row of -4 and -6 and the third row of 2 and 3? Still, that is not
See,
clear.
I'll tell you. See, this is multiplied by 2.
This time the second row is clear. The third and fourth rows are not clear.
Right.
The 3 minus 4 is how much?
Minus
3 minus 4.
3 minus 4 minus 1.
Minus 1. Minus 1 into this.
Okay, sir.
2, 3.
Okay, sir.
Again,
That is
4 minus 6 plus 2 is how much? 4 minus 6 plus 2 is how much?
4 minus 6 plus 2 is 0.
0. So 0 into this, 0, 0.
Okay, sir. Thank you, sir.
You just practice it very, and logically also very, this is also, logically is very good, because why you are, this one has no meaning, because it is 23 less than, 23 more than 123. So this is 23 is important, not 1. This 1 doesn't matter here. So this also, Paravarta is exactly the same, transpose and prime. Transpose, you are transposing the, direction of the deficiency of more, something like from the 10th power 100 here in this case. So accordingly you are doing it. It is almost some Nikilam, like Nikilam method, but it is called Paravarta method. But it is the opposite of that, so therefore it is called Paravarta.
The last line 2 minus 0 1 2 minus 1 0 converts into 190.
Vinculam,
Okay.
2 and 1, like this. Go to 19. Earlier we did now Vinculam.
Oh, okay, okay, okay. Okay.
Vinculam.
Oh,
This, it is written explicitly in -1. It could have been written instead of that. I could have written like this.
right.
I
Okay.
could have written 4 and 6 this way also. So
Right.
you can write that way also.
Okay, good. Okay. Thank you, sir. Thank you.
Now it comes to this. So far you have handled only. Let me, if you
Now,
permit, let me finish at least one more this thing.
Gautam
After
ji,
that we'll go to up to recurring decimal. Will just end.
Gautam ji,
I'll complete this thing.
Gautam
Yes.
ji,
Yeah, one
now
point.
it's already past 8 o'clock.
No. Is it? Oh yeah.
Right.
No, I'll just let me. This I'm telling that if you permit me 5 minutes, I will at least this concept I will tell how it is extended for this.
Why hurry up?
Sir, a request, please don't hurry up. Yeah, because of time. Yeah,
This we will do tomorrow.
right.
And actually, what
Now,
you know,
what I want to say, okay, this is fine. I want to say that, as you know, we left up to remainder, but actually, the purpose of division sometimes becomes how to get more, more digits. I mean, in the decimal format also. Here also, you'll see that we did the same thing. 30 are dividing by 8. We can go this way. Detail will go tomorrow. And we keep on 0, putting on 0. I'll put a decimal point here. And that will go. It becomes 3.75. But by the Nikhilam method, we actually can go. This is 22 by 7. You know, this pi, the simpler pi, 22 by 7. So we 3.142857 we get. How it is getting? Every time we are adding on 0 and putting that remainder again with starting with the 0. And with that we are doing, and this way we are doing. So I just okay. If you like, you can add. If you like, you can add. Stop it here.
No, why I wanted to have a break is, see, there are some feedback, from people today.
Okay.
So we can discuss that and then take it forward.
Yes, please. So we can discuss, right?
Yeah, Badri Mahodaya, what he was telling is, you have given a book, and the problems in that he can't solve with the methods we have explained in the class. So you correlate these two in the sense that you have taught some methods in addition, subtraction, and multiplication, and all those things. Based on that, you give us some problems for working out. If it is in the textbook, you can say, okay, exercise 1, 1.2, 1.3, 1.4, and use these methods, one of these methods, and we can solve these problems. And then the answer is already there in the textbook, I think. Key is there. So no problem. But if it is not so, if the textbook is different and what method you are teaching is different.
No, method I'm not teaching different. I mean, examples are maybe different. Examples
Methods based on this method, can you list out some problems from the textbook and then give it to us so that we work on that? That's what Badri was talking about.
Okay.
So what we do is that, if not now, after, you take your time and give me some problems, at least 5, 6 of them, or one each in all these methods, one each. Okay, on this method, this problem, like that, if you give it, those problems we will.
No, will it be easier if we share this my presentation directly?
This any case, we will share.
Yeah. So he can take the example from this example itself. The discussion
for them to practice now.
They can put their own numbers and practice. No.
Homework by the teacher is always very good.
Yeah. So what can be done?
Whatever you are asking us to change, you change and then give the
please. So I am narrating. Can you please note down, all of you?
Sir,
I am giving it here. I am giving it, writing it here.
I think we are passing out the time. That's.
So see, instead of I tell you 23431, kindly change it to 27831. Or you only change to 78. And here 35642.
Okay, then what is the answer?
359662.
Then what is the answer is the problem now. Actual problem is that.
Sir, you can see by your mobile calculator. Just verify it. You do it and verify by calculator. I always do it.
That is
I learned by also that one. You always verify through calculator.
Yeah, that is of course.
You change it. You write.
Okay.
As I told you, write bigger numbers. Okay. Write something like 89. And here also 64. You change to 89. Let us see what happens. Okay. 89 or 87, something like that. And accordingly, vinculum you have to change. So then you whether you're getting the same result or not means that you can devise your own problem now. Okay. Otherwise, you change shortly. You small changes you make from the given examples and do it.
Yes, sir. Yes, sir. What you are saying absolutely right. The teacher is saying devise the problems. Answer is you do it in a calculator or your own method and see whether the answer is coming or not.
Yes, importance is by learning the method, where you got the method properly or not. That here you have seen that I showed you that it is how it is crossing. The, four kinds of process, 5 kinds of process are there in case of 5, 3 digits. Then in case of this one, we got even we have not shown. There will be more digits like this. I'll show you.
You are starting a new one.
I have a small doubt. Like, by knowing the meaning of these methods, like Tiryag method and all that, probably we will have a better clarity. Like, will it give some additional information? Like,
John,
meaning Tiryag. What is Tiryag? Oh.
Theory of this. A theory I am discussing, no? They will all cross. Theory I am discussing side by side, no?
Okay.
I told you the theory of this particular method.
మంజు రోడ్డు కిందకి పైకి వెళ్ళే బదులు ఇక్కడ ఉతికే ఆరేసుకోబోదు 2 ఫ్లోర్లు
theory is here.
ఈజీగా కష్టంగా లేదా?
See, it is the same thing. Grouping is different. It is the same thing as our conventional method, but grouping is different. Grouping is like this.
Okay.
Grouping is 10,000 group, 1,000 group, 100 group, 10 group, and in the very first place we are grouping it.
Okay.
Therefore, unit digit is coming in the very first, in the top.
Okay. Thank you.
And unit digit from the sub calculation actually. Later on, it will be modified by the adding by the carrier, adding with the carrier. In our case, what you have to do? We have to multiplying this number with only R in the top level. So it becomes 100 AR plus 10 BR plus CR in the top. And then below, you shift one below, it becomes 1,000 AQ, 100 BQ plus 10 CQ.
How long you want to take?
Towards left. And then in the last row,
excuse me, Gautamji. How long you want to take more? People are saying that they have other.
Achha. No, I can stop it. I was only answering the questions.
Okay. So what we do is that we will close it and tomorrow we will continue.
Yeah.
Okay. So let us do prarthana and then Janaganamana. Sarve bhavantu sukhinah, sarve santu niramayah, sarve bhadrani pashyantu, Ma kaschit dukkhag bhavet. Om Shanti Shanti Shanti. Let's have Janaganamana now.
Right.
Babu.
Hope all others are muted.
Yeah.
Okay. जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उज्ज्वल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हिंद
Jai Hind.
जय हिंद जय हिंद.
Thank you, Babu.
I think we close.